Welcome to SIM-PAC Live. I'm your host, Jeff Matthews. For centuries, wind power has shaped human progress. From the vertical axis Persian windmills, turning grain into flour 2,000 years ago, to the towering horizontal axis turbines, powering entire cities today. But what if the future of wind energy looks less like a propeller and more like a spinning sculpture? Early in the 20th century, vertical axis wind turbines, or VAWTs, briefly captured the imagination of engineers. They offered a sleek, omnidirectional alternative to traditional windmills, but materials limitations, structural fatigue, and low efficiency kept them grounded. So much so that today, nearly all of the world's wind energy comes from horizontal axis turbines, HORTs. But can 21st century breakthroughs in material science, aerodynamics, and computational design finally allow VAWT technology to rise from the ancient ashes to play an important role in our future energy landscape? Today we interview Gary Andrews from Vortex Energy Australia, a company whose advanced designs gives promise to the commercialisation and widespread adoption of vertical axis wind turbines. Welcome, Gary.
Yeah, good morning, Jeff. Thanks for having me on your program.
Thanks for coming on the show. Really looking forward to our chat. Now, Gary, bring us up to speed of how we get to today. So when did you first become interested in VAWT technology, and how did you bring this technology back to Australia?
I first got interested probably back in 2016, and the technology, I was working with China Railway Engineering Corporation at that time, and I was looking for business development opportunities with other companies, and I came across this vertical axis wind turbine technology that had been developed in the UK by a guy called Michael Blaze. His background was a designer in the Formula One racing industry, and then he moved on to the large wind turbine industry, and eventually went out into business for himself and designed these vertical axis wind turbines. And anyway, long story short, I ended up buying the technology and in 2018, and moved back to Australia in 2019 to set up Vortex Energy and start developing the technology further.
And you're working with Flinders University?
Yes. One of the first things I did when I got back, apart from speaking to government, to find out about any assistance that I might get, was to do an innovative advanced manufacturing program at Flinders, which was about a 6-week program. And as a result of that, I met Dr. Amir Zanj, who's an aerospace engineer, and he was already interested in wind turbines, and so took an interest in the turbines I was trying to develop. We developed an informal relationship, and from that flowed a more formal relationship once I received investment with the university. We signed an MOU with them in when was it? In June 2023, and
Yep.
I'm based at their Tonsley campus, and am able to use their facilities basically as part of that memorandum.
Right. And just to clarify, you got initial funding from a private investor?
Yes. That was a long journey. So we were trying from 2019 through to, but eventually in August 22, we managed to get the interest of a businessman that had just sold out of a very successful company that was involved in the manufacture of telecommunications towers. And so he had the funding and he had the interest in our turbines, and also he was in the process of building up a group of companies, all involved in various aspects of renewable energy. So it was a nice fit. So he invested a small amount to begin with, and that on the back of that, we were then able to, because to be taken seriously, you have to have dollar for dollar basis if you're going to be getting any assistance from government. So that put us in a position to apply for some grants, and we eventually got a seed grant from the South Australian government. That was also in 2023.
And that allowed you to build the prototype that's on screen at the moment. And tell us about that journey of getting that prototype built and out the door, and also the advanced design work you did from the initial UK technology to that prototype going out the door.
Well, first of all, we had to spend a lot of time understanding the technology. We had all the intellectual property that they had built up, which included patents. By the way, we have patents in China, the US, and the United Kingdom. So yeah, first of all, a lot of work done to try and understand the technology, and our first step actually came before we secured the investment. So together with the university, we built a 1/5 scale model of our technology, and also a wind tunnel to test that model. And the idea really of that, it was a working model, by the way, was a demonstration of the technology. Until we did that, it was impossible to get investment. So once we did that, that was a great help. And then back to your question, with the investment, we were able to build this prototype, which took us a lot longer than what we had expected, because it was in the middle of COVID, and or in the tail end of it at least, and all the supply chain problems that resulted from that. So it took us about 12 months, and on top of that, it was a learning process for everybody involved, because nobody has manufactured a wind turbine here in Australia before, certainly not in South Australia. So we eventually finished the prototype early this year, and it was installed down on the Flinders Peninsula for testing in February.
And how have those tests gone? It's obviously still standing and still spinning.
Yeah, I mean the tests have been. It's accelerated our progress because we can finally gather physical data to verify all the simulated testing we'd done prior. And one of the drawbacks in the past of vertical axis wind turbines is their ability to self-start. That's always been difficult. We were claiming from the simulated testing that ours would self-start, and the physical testing has proven that it does. It's also enabled us to refine a control and monitoring system that we had built alongside the prototype, and that's been a big learning process as well. But as a result, it enables us to remotely monitor the performance of the turbine. We've got a whole lot of sensors implanted in various parts of the turbine to measure things like vibration on the bearings. We have wind speed monitors. So we've been able to learn a lot since we've had the prototype in the field.
Okay, so let's come to why VAWT. why would you go vertical axis wind turbine? I've made some notes about what I see as the advantages of your technology, and yours in particular, because we know that there's other VAWT designs out there, and no one's really commercialised it at scale. I'm going to read these out, and if you could give us the rapid fire, rundown on each of these points, and that might give everybody a sort of bring us up to speed on why you would consider VAWT technology. Firstly, omnidirectional wind capture.
Yeah, well, that's omnidirectional means we basically don't need to turn it into the wind, which is what needs to be done with a Hort, and they do that either with the smaller ones. It's usually with a flap that captures the wind direction and points it into the wind, or the bigger ones you see in the wind farms, they actually have to have a motor. So either way, it's extra complexity, extra parts, more maintenance. So that's the benefit of being omnidirectional, and it also enables it to handle gusting wind more easily, and we wind switching positions back and forth quickly.
Yes, and another sub point, I gather it allows you to build, if you put them in a farm configuration, the turbines much closer together, because they don't you don't get sort of the wind shadow effect, or they can positively affect each other.
Yeah, a couple of years ago, and I'm sure there's been other studies as well, but a couple of years ago there was one done by Oxford University where they looked at the placement of vertical axis wind turbines in a wind farm configuration and found that they actually placed in a correct pattern, they actually benefit from the turbulence of the other turbines in the wind farm, which is something that the Horts do not. It's detrimental, so they have to be spaced a fair difference apart, which means in a wind farm configuration you need a lot more land to place those turbines than you would for an equivalent size vertical axis wind turbine. Also, it means that it would be feasible to, in those big Hort wind farms you see, to place smaller vertical axis wind turbines in amongst them.
Interspersed, yeah. Okay, the compact design, and you could also sort of throw aesthetics in there as well, because I think the design of the first sort of VAWT piece of technology I ever saw was actually a sculpture in a park, and so they're very different than a big propeller. And so, tell us about the compact design and what it enables you to do.
It's not so much a compact design. It's an aesthetic design. It's what's the other? It's a simple. The key thing is it's a simple design. So, but very complex in terms of the design, in developing the design.
Yes.
But in terms of moving parts, for example, it has 4 bearings compared to 26 bearings in those large wind turbines that you see in the wind farms. We have 2 designs, a helical design, which is the one that is pictured and is used in our current prototype, and we have a H-bladed design. Certainly, we've had a lot of feedback about the helical design because people can now see it there, and the general conclusion is it's very attractive. And
yes, I think the human brain likes the infinite movement of it.
Yeah, maybe there's it looks very much like the human DNA helix shape, so maybe there's a subliminal connection.
And with that design, quieter operation?
Yes, from our we were we understood that vertical axis wind turbines are quieter, and our experience with our prototype is basically it's the sound of the wind. We want to measure, we will measure exactly the number of decibels that are being emitted because it's an important feature, the quietness, and we want to be able to quantify it carefully. But at the moment, we haven't reached that point. But yeah, our observation is it's just the sound of the wind.
And also a second point of sort of acceptance is safety, especially for wildlife, bird life.
Yeah, there's studies that have indicated that vertical axis wind turbines are safer for birds, and the reason for that is basically the tip speed ratio of the blades is the same all along the blade, so it makes it more visible to the to a bird than the horts, which are spinning at the tip of the blades of those horts is travelling very, very fast, and the point of the blade near the axis is quite a different, slower speed.
Yes.
And it confuses the bird.
Yes. Visually looking at it, that makes sense. Coming back to the turbulence tolerance, that also would enable you to position these near buildings and in an urban environment where you've got turbulence with wind swirling around things.
Exactly. There's and that's one of our target markets in urban areas, at factories, on top of buildings, along railway tracks, etc. Because they cope with that turbulence, and there's a lot more turbulence caused by the structures in an urban environment. If you've ever, I note every time I walk into Flinders and I get near the tallest building there, you get a strong gust of wind near the corners of the buildings.
Yes,
and you get that effect in more particularly so on the roof of those buildings.
Yes, and also with your smaller, I think it's a six kilowatt size. There's mobility. You can actually anchor these with concrete blocks and pack them up and move them. Is that correct?
That's correct, yeah. And by the way, we have two designs at the moment. The smallest one being the 6 kilowatt, as you've mentioned. Our largest one, which we haven't built yet, but we have the design, is an 80 kilowatt. Yeah, one of the features we have added to our 6 kilowatt prototype is that it is portable. We can assemble it and move it within a half a day. Instead of having foundations set in the ground, we have foundations which have to be larger as a consequence, but they're sitting on top of the ground. And in fact, with some further development, we think we can make those a bit more compact. But yes, at the moment, and certainly in the future, that'll be an option with our turbines, because, for example, construction companies which have indicated an interest in our turbines, they're shifting work sites very frequently and need to be able to pack up and move those a turbine if they were to use it easily.
And I would imagine the military might be interested as well, because they're always looking for portable electrical generation that they can move about quite quickly and deploy.
Yeah, we had thought of that. We'd very much like to have a model adopted by the military for perhaps for their remote camps, if you like, and to power their telecommunications and other things.
Gary, those are all really great advantages, and I can see that time has moved on, and with it science has advanced, and we've got better computational design abilities, we've got better material science. I note that your blades are made of carbon fibre, And I also think that we're now looking for alternatives to just big turbines, because we've got solar. If you're looking on a small, medium size, you've got solar, and then you've got a big wind turbine. And I can see these supplementing solar, especially now we've got batteries coming on as well.
Absolutely, yeah. We think the best solution for renewables in any situation really is a hybrid solution, combining wind, solar, and battery. And if you want absolute certainty, probably a backup diesel generator, and eventually replace the diesel with hydrogen, ideally. So yeah, hybrid solutions are ultimately the best. We if I may,
Yes,
I'd just
continue.
like to. You mentioned at the outset that and we've talked about the advantages. We haven't talked about the disadvantages. One of them I've alluded to already, which was in the past they were VAWTs were very. It was hard to get them to self-start. They needed a motor to kick-start them. Our technological advance has been in the design of the profile of our blades, and that is what has been patented, as well as an eddy braking system that we developed. But that profile makes our blades more efficient than any other VAWT in the market, and equally as efficient as the best Horts.
Right.
So that's so we have self-starting ability, and we've demonstrated that we have 38% efficiency.
Yes, you can see that was a matter of time, and because if you're dealing with aerodynamics and the wind, you could see that was a matter of time to be able to close that gap in efficiencies.
And you were right before in terms of the advance of the design tools that have come over past years. That was part of the problem with VAWTs in the past. They were poorly designed, and as the Horts took off, they had a lot more money behind them and could deploy the best design techniques and the best tools. The VAWTs were left behind. Well, we've been able to use those same tools and same design techniques to advance the design of our turbines. Part of that, what we've done is develop an artificial intelligence assisted generative digital twin of our turbine, which at the moment is focused on the control and monitoring of our turbines remotely. But ultimately, we're further developing that so it becomes a design tool and enables us to either scale up or scale down our turbines virtually and get the design to a point where we believe through testing, simulated testing, that it's good enough to build a prototype. So it should save quite a bit of cost in hit and miss on prototype development.
And how far are you away from a larger scale or commercial turbine being produced?
We will have well, firstly with the larger design, the 80 kilowatt, as I said, we have a design, but we wanted to start with the smaller one first for the reasons of getting to know and understand the technology properly at a more manageable scale. The larger turbine, by comparison, our 6 kilowatt has blades that stand 5 metres high and 3.4 metres wide, whereas the 80 kilowatt, the blades are 19 metres high and 11 metres wide. So it's a significantly larger piece of equipment. With that, we've just started doing simulated testing to verify some of the performance testing that was done by the developer. But with the 6 kilowatt, having already done a prototype, we expect to have a commercial model in by March next year.
Right, and a commercial model would mean that you're ready to manufacture it. You obviously go from a bespoke one-off build to manufacturing something that's repeatable, going out of a factory's a different process altogether as well.
Correct. Yeah. We've actually got a project in train at the moment with funding from the federal government. Manufacturing Growth Accelerator grant to refine the manufacturing process for our blades, because that was the most complex part of the build of our prototype, and it took an excessive amount of time. And we need to analyse first the reason the blades were designed. The structure of the blades was designed the way it was, so we can understand what it means for the strength and performance. And then when we've done that, we're looking at how we can modify it without diminishing those performance benefits. We want to modify it in order to make it a lot easier, quicker, and cheaper, therefore, to manufacture at volume.
Yes, and I've the City of Salisbury is sponsoring SIM-PAC Live South Australia this year, and I know they're looking to attract manufacturing businesses to their city. So I'll put you in touch.
Thank you. Yeah, we'd be interested in talking with them.
Yeah, no, they're good guys, and they've attracted some good companies out that way. So you wouldn't be alone there. Now, what next for you? I mean, obviously, scaling up and becoming commercial, you've got to have a market, you've got to have a product, and you've got to have some money to get to that market. Your route to market from here to push these out into the world?
Yeah, well, at the moment, having got our prototype, getting the data in on through the testing, we're looking to see how we can modify the design slightly to improve the performance even more, but quickly, because we want to get that commercial model out by March. So that's what we're doing, and we realise that our aim is to be able to manufacture these in-house rather than using outsourcing to suppliers for the build, because we learnt that other suppliers are not just working for us; they're working. They're obviously working for. They have to tackle our priorities with the priorities of their own business and other customers. So we want to do it in-house to be able to have more control over the manufacture. Now that's going to take quite a bit of money. So we're focused now on looking at raising more funding to allow for the growth of the business. Ultimately, we think we'll need about $5 million, but the first step is we're aiming for about $1 million by March next year.
And I gather your first investor is also helping you raise that capital. They've been in that field before, and so they're the ones that are helping drive that.
Correct. Yeah, he's having built and sold one company, and now having built a group of companies comprising about 12 individual companies in the renewables area. He's raised quite a bit of finance in the past, and so his assistance in raising capital, equity capital for us, is invaluable.
Yeah, great stuff. Great stuff. So, Gary, tell me the sweet spot you see in the market for your product, both in terms of kilowatt size and also market segment.
Well, we're most advanced with the 6 kilowatts, so obviously we're looking at first at where the market might be for those. The sweet spot in terms of the capacity of the turbines is going to be the 80 kilowatt. That's where ultimately most of the interest has come. But there is interest from construction companies, mining companies, um, building developers, uh, aged care um, owners of aged care properties.
Yes.
We've had approaches from those sorts of people. So and they have a direct interest in our 6 kilowatts. So that'll be the starting market, and here in Australia and possibly New Zealand, to get us started. Further down the track, we would like to export as well.
And I would have thought some of the South Australian vineyards might be interested as well.
Yes, they are. I should have mentioned that. So we've had a lot of interest from farmers and a number of wineries.
Yeah.
There's been a wide spread of interest, actually. Unfortunately, we haven't been in a position to say, yes, we've got a turbine for you. We have to tell them, can you wait another 12 months? We've had approaches from a whole lot of different areas in the market, and one that's been reasonably consistent and of great interest is from remote communities and island, not as in the Irish, but islands,
Yes.
island communities.
Yes.
For example, we've had a number of discussions with people from Christmas Island that are interested in wind turbines there. One of the criteria obviously, one of the criteria for island communities is space. Depending on the size of the island, or even regardless, space is at a premium. So solar, large solar installations are more problematic in those sorts of circumstances, and wind is a better option, providing the right wind conditions are there. So that is looking like a good potential market for us. And then in terms of remote communities, for example, First Nations communities in Australia, they're often very remote. The costs of they're often run using diesel generators. The costs of
Yes.
joining them to the national grid is not viable. It's too expensive. So using renewable energy would be ideal. And we believe that our
And the wind profile, when it blows, especially at night, would be ideal for, combining with some solar as well. But it would give them a better 24-hour profile.
exactly. I mean, in all of these situations, I mentioned islands, remote communities where currently they're managing with diesel generators, which involves good logistics for resupplying with
Yes.
diesel. Well,
Yeah.
there needs to be resilience in any solution, and so because solar is intermittent, wind is intermittent, you need a hybrid solution. Certainly a battery, and
Yeah.
we've been talking with a couple of other companies actually that about hybrid solutions, and they still deploy diesel generators, but they use about 90% less fuel in a hybrid renewable arrangement than just a diesel on its own.
Yes.
But it gives that absolute certainty that you've got 24/7 reliable energy, which is really the only downside of renewables on their own.
Yes. It's coming. It's coming fast. Right, Gary, that's all the questions that I had for you. If anyone wants to ask Gary a question, you can put your comments into the live chat now. Gary's online. I'm online. We can answer those questions. And thank you very much for joining our show to the audience. And thank you, Gary, for coming on. It was great. I wish you the best of luck. We'll see you at SIM-PAC Live South Australia.
Thanks, Jeff. Thanks for having me. And I'll look forward to it.